Alrighty, welcome to yet another set of notes for quadratic applications. So what we're going to do here is we're going to devise methods to set up application problems involving quadratics and then evaluate to find a reasonable answer. Okay, so let's look at the first part here. What I want y'all to be able to do first off, and this might take some remembering, is being able to, you're going to have to know how to remember how to multiply. Distributive property, box method, whatever. So let's look at that first, okay? Alright, so here's one that is slightly different from what I may have shown you earlier in class, but what we're doing here is we're saying 2x times 4x. Whoops, let's try that again without an eraser. When we distribute, we just want to say, okay, we want to make sure the term on the outside multiplies both terms on the inside. Now, you may need to write this, you may not need to, but I'm going to go ahead and write this step. So I'm going to say 2x times the 4x, and then I'm going to say 2x times the 7. Notice I'm not worrying about the negative 7, I'm just bringing that straight down. Okay? So 2x times 4x would be 8x squared, and then 2x times 7 would be 14x, and then there's that minus. Now, if there had been like a negative or something else, maybe I put a negative, it gets kind of complicated, but this is fairly simplistic right there. Now again, how do I know this is x squared? X times x gives me an x squared, so there's two x's. X times no x gives me an x. So that's distributive property, and that allows us to do different other types of problems that might involve, say, that type of situation. So the first method, when I want to multiply, say, two linear terms or polynomials, functions, is to say, go ahead and do, like, say, multiply them out, and then kind of go, like, using what I call the vertical method. Should be similar to two-digit multiplication. So with the vertical method, what I do is I go ahead and write one of the parentheses under the other. And the idea is this, that you take the first number here, like this 8, and you're going to multiply it to both numbers up here. So I'm going to say 8 times negative 7, and I'm going to read these as positives as negatives. 8 times negative 7 is negative 56, or I'm going to write minus 56. 8 times 2v is 16v. So I went up, and then I went across. Then I'm going to, when I start to multiply this one, I'm going to start on another row, start at 0, so I'm going to start under the second column. 4v times a negative 7 is negative 28v. By the way, this was a positive 16. 2 times 4 is 8v squared, because v times v gives me v squared. Now, the reason why I like the vertical method is you notice these line up very nicely. So I can go, okay, 16 minus 28 is negative 12v minus 56. So you can kind of see here how that works. It's fairly easily simplified and organized, and you have it like that. Remember, these are all should be just review. I'm just covering this because some of you may need this to help you get through the part of what we really want to cover. So distribution method, let me back this up a bit. But the distribution method is very similar. What they do here, all these are basically the same thing, just how you organize. So what you do here is I split the first parentheses and say 4v plus 8 like that. And I'm going to put the numbers in the second parentheses, the 2v minus 7, into both. So basically, I'm going to make sure that I'm going to multiply the 4v times the 2v minus 7, and then the 8 times the 2v minus 7, as so. 8v squared, and you can see how they multiply. Then you should be able to combine the two numbers in the middle, and that's where I get the 12v. So notice, same example, different ordering, but I get the same answer. So that's the distribution method. And then the last method I'm going to cover is the box method. The box method basically says you write one number, or one of the parentheses like on top, and then one on the side, and then you multiply. 4v times 2v is 8v squared. 2v times 8 is 16v, and that's a positive. 4 times negative 7, negative 28v, and then I would have negative 56. Combine those two, you're always going to, should almost always, at least in these examples, combine those two right here in the middle, like that, and that gives you that one. So there you go, and those are those three methods that we need to maybe, say, solve these types of problems. Okay, so what does that lead us into in this? Okay, so here's an example from the worksheet y'all were working on earlier. The length of a rectangle is 3 feet longer than the width. The area of the rectangle is 270 square feet. So how can I come up with a method to set this up? Well, the first thing I would say is draw a picture. So when you draw a picture, okay, so draw a picture. We're talking about a rectangle here, so I would draw a rectangle, and they tell you there's a width, and that the length is 3 feet longer. So 3 feet longer than the width, so plus 3. Longer means plus. Okay? And then we're talking about area, and how do we get area? So now we start trying to, like, say, set up the problem. Okay, so you've got this picture, now you want to set up the problem. So I'm going to say, okay, well, I know the area is 270 square feet, but how did I get that? I got that by multiplying these two. So I'm going to multiply W times W plus 3. So this is like where we do the distributive property. And that will be equal to 270. So that gives me W squared plus 3W equals 270. Now, at this point, now you want to say, this is your setup, and this is going to be very important. Now you want to say solve this. And you solve this by any means necessary. If this was the TSI, obviously you wouldn't have a calculator, but you can go ahead and set this up on the calculator using like the quadratic formula. If you move the 270 over here. On the TSI, you would probably be able to go ahead and factor this type of problem and come up with an answer. Okay, so we could factor this and come up with an answer, but that's not going to always work in every case, as I discovered in, like, say, another example of this in a second. So what I'm going to do is I could say use the quadratic formula. Now remember, the quadratic formula says x is equal to, or w in this case, negative b plus or minus square root of b squared minus 4 times a times c, all of that over 2a. The nice part is on the Inspire calculator, you can type all that in and then give me the answer. And we don't need to worry about the this time I don't need to worry about simplifying this. I want decimal answers. This is an application, so if I get an answer of like 11.2, then I want 11.2. So I can plug this in and say here, for that one, that I could have said, all right, negative 3, because A, B, C, negative 3 plus or minus square root of 3 squared minus 4 times 1 times negative 270. All of that over 2 times 1. If you do that, what you will get is, and you can press Control Divide to get this fraction thing, but if you do that, what you will get is, and I will show it to you here. Okay, so you can see here, I typed this in. To get this, by the way, just press Control Divide before you start the problem, and then you type in everything. Okay, and again, notice all I did was plus and minus. All you got to do there is press up 2 times, press enter, and then you can change the plus to a minus. Anyways, I get positive 15 and negative 18 for answers. Only one of these can work because it's an application problem. And obviously, we will not count the negative answer. All we care about is the positive answer. So I could find out the width is 15 feet. So the idea here is try to see if you can set up different types of problems. I'll give you one more example. Okay, so here's another example. A rectangular lot is 8 meters long and 7 meters wide. Okay, so if I draw a picture, that one's 8 by 7 or something like that. When length and width are increased by the same amount, here's a big key, increased by the same amount, the area is increased by 100. Okay, so I can see here the area of this is 56. But we're going to increase this by a certain amount. So like, I'm going to add so much, and I don't know what that is, so I'm just adding X amount. I'm just going to say I'm adding X. So this would become 7 plus X. So now, the nice part is there, for this, I know I'm adding this to make this 156. I added 100 to the 56 because that increased it by 156. You can say X plus 8 or 8 plus X. So I'm going to say it like this. X plus 8 times, x plus 7 equals 156. Okay, so now I can multiply this to get what I need to, which in this case I should get x squared plus 15x plus 56 equals 156. It's important that you make sure you kind of keep this in there, because I know like you might be thinking, oh, I could have just put in the 100. Well, no, you couldn't, because watch what happens. X squared plus 15x minus 156. Now, mind you, this right here is what I would have asked for if I asked you to set it up. Gives you negative 100 equals 0. And now I can solve this, and I can solve this by whatever method I can figure out. So like here, okay, so if I do this, I get that he either added 5 meters or I added negative 20 meters. Which one would make sense? Obviously the 5 meters would make sense, so my answer is that you would add 5 meters to each both sides of the length and the width. Maybe there's ways you can kind of guess and check your way to this answer, but this, honestly, folks, is supposed to be the most efficient way. And that's really what algebra is about. Not that we're guessing and checking for something that fits one specific formula, but that you can kind of come up with an idea that could work in all situations. Anyways, hopefully that answers most of your questions that you may have. If you do have any other questions, feel free to ask in class. Hopefully this does well for y'all. Y'all take care. Thank y'all. See y'all tomorrow.